Hello, Royals. Let's take a look at lesson 3.1 on rational exponents. I want to make sure that we're using the proper notation. When I write something like 2 to the exponent 3, 2 is the base, 3 is the exponent, 2 to the exponent 3, or 8 is the power. It is very common outside of math classes to call this 2 to the power 3, but 3 is not the power. You can say that the third power of 2 is 8, but that still doesn't make 3 the power. That is the third power. Um, the way that we were taught exponents was probably through repeated multiplication. And in grade 11, things get a little bit more complicated, and we might have to let go of that model a little bit. Often students tell me that 2 to the exponent 3 means 2 multiplied by itself 3 times. They usually get the right idea. But I just want to illustrate that if we do a pattern down here, when I do 2 squared, is this really 2 multiplied by itself twice? Isn't there just one multiplication? If I try that explanation out for something like 2 to the exponent 1, is this 2 multiplied by itself once? Of course not. Let's try to think of it instead as the number of factors. 2 cubed means there are 3 factors of 2. 2 squared is 2 factors of 2. 2 to the exponent 1 is 1 factor of 2. Now, in every single one of these situations, there was always an infinite number of factors of 1 that didn't need to be listed because they were invisible. And that gives us another explanation to supplement what was in the lesson. Why 2 to the exponent 0 is going to be no factors of 2, but there is still going to be that factor of 1, which now becomes visible. The patterning that I referenced in the lesson goes like this. If you can convince yourself that 2 cubed is 8 and 2 squared is 4 and 2 to the exponent 1 is 2, then you establish a pattern that these powers are being halved as the exponents decrease by 1. So that will help you avoid the most common mistakes of thinking that 2 to the exponent 0 is going to be 0. It'll also help you with the integer exponents. These are natural exponents. Here's a whole exponent. We go down to integer exponents. Now, this isn't 2 multiplied by itself -1 times, but it's also not really -1 factor of 2, although I could stretch that explanation a little bit. When I have a positive number of factors, that ends up with a multiplication. This right here you can think of as a deficit of factors. Perhaps 2 cubed means there are 3 more factors in the numerator than there are in the denominator, like with our exponent laws. If I write 2 to the exponent 4 divided by 2 to the exponent 1, that means that there are going to be 3 more factors in the numerator than there are in the denominator. So there is a surplus of 3 factors in the numerator. Here there's a deficit of 2 factors, which means that there's going to be 1 more factor of 2 in the denominator. That would follow from my patterning as well. Half of 8 is 4, half of 4 is 2, half of 2 is 1, half of 1 is 1/2. I like using the idea of reciprocating the base. That is the reason why we could identify the reciprocal of a function, 1 divided by f of x as f of x to the exponent -1. But it's nice to know that there are ways that we can figure this out as well. This does actually work for fractional exponents as well. If we take a look at something like 9 to the exponent 1/2, this isn't 9 multiplied by itself 1/2 times. That doesn't make any sense. But I could argue that 9 to the exponent 1/2, which in our lesson we should have figured out meant the square root of 9, is half of the factors of 9. Well, what are the factors of 9? The factors of 9 are 3 and 3. Half of those factors would just be a 3. And that makes sense when I say it out loud, when I explain it in English. It's fine if you end up understanding that 9 to the exponent 1/2, that this denominator tells you which root you're taking, and then you're raising it to the exponent 1, and that's why you get the answer of 3. But make sure you understand why those things are true. Okay, try that out.